Hello and welcome guys, and in this tutorial video we're going to be looking at the HackTheBox machine called DAB. So I've already done the initial scan, so in order to do that we could do nmap.sc-sc sv, then the IP address 10.10.10.86, which is for DAB. So initially I run the scan. If I do a list command, I've got it here called scan. So I'm just going to cut that scan to see what we've got. And in the scan, we've got a port 21 FTP service running, SSH on port 22, HTTP Apache service or Nginx running on port 80, and also port 8080 also running HTTP service. So the first thing we do is, let's have a look at this first port, which is the FTP port. So we could just do cd HTTP, cd dab, and then we do FTP 10.10.10.86, and we type in anonymous, no password, and we logged in. If we do a list, we've got a JPEG file, which if I list here, is what I've got here. So I can just go into my home directory and search for dab.jpg, and all we got is just a picture. So there's nothing, to look further into this. So next thing we need to look at is the port 80 service. So we could do 10.10.10.86, and we're presented with a login page. So we could do admin, login, and we get an error of login failed. So what I did in this case was to start up burp suite, go on to preferences, advanced, settings, and enable manual configuration 127.0.0 and also on 8080. Click on OK, and then try to send this request through burp. So in burp, I go to the proxy tab and intercept is on, and just send this request. So burp intercepts that request, and you can see here we've got admin submit. I'm just going to send that to repeater, intercept off, click on go, and we've got the error failed login. So in order to make this video quite short, I've done the list of commands. So if I do cat commands, we could use W4s to enumerate the username and password parameters, and force it using some word lists which you could get through seclist. So if you just go on to Google, for instance, and search for seclists, you could download seclists, which is a collection of files containing web shells, password, miscellaneous that you can use to force. So I'm just going to copy this command to make things quite easier. So let's exit this shell. I'm just going to talk through this command in a little bit. So we've got W4s. We specify the word list we want to use. So the word list we want to use is the top username list.txt, file, password. We're using the dark web 2017 top 1000.txt word list. If we have a look, so we could do W4s, go onto the help page, and we can have a list of the different parameters or options we could use for W4s. So typically you have W4s and then you have the options, so .z for the payload and the parameters including URL. So what I did in this instance was use W4, specify the file, HC to say we're looking for ports. So let's have a look at what HC does. So in HC, here we can see that we're saying hide responses from specified code lines. So what I'm going to do first of all is to get rid of this. Let's get rid of this. HS here is to say don't look for anything that says login failed. So that's the error message we got. We specify the parameters. D is for post request, so username, password, FOS and FOS to Z, and then the URL for this. So let's just run this and see the response we get. So we're trying to brute force the username and password. So you can see we're just getting a bunch of 200s. So that was why initially I specified using to hide the code 200 and also 500 for failed error messages. So we run this and see what happens. So you can see here we've got a code response for 302. I'm just going to end that saying the username is admin and the password is password1. So let's attempt to put this in, admin and then password1, and we're logged in. So we're logged in into this page, welcome admin, and just a list of items about some stock items. So nothing interesting here. We can have a look at the source code. And here it says debug data tables are loaded to an SQL database. So nothing quite interesting here. However, if you remember in our initial scan, we found a port 8080. So I think it'd be interesting to have a look at what the port 8080 gives. So here we go into here and says access denied, password authentication not set. So let's have a look at the source page. Nothing quite interesting, but here he's saying that the access is denied based on an password authentication not set. So what I did in this instance was to send this as well to burp. So let's go and turn on intercept on and send this to burp. Intercept the traffic, and then here we can see we've got a cookie session. So we've got a cookie which is set, and if we send this to repeater, turn this off, go to repeater, click on go, we have the access denied message of saying cookie parameter not set. So we're saying here password authentication not set. So what I did here was to go to the parameters, added a new parameter, called this a cookie, and typed in the word password here and just put a random password. So I put in test, go on to raw, click on go, and you can see the response we get here has changed from before it was password authentication or set. Now it's saying password authentication cookie incorrect. So armed with this new information, we could try to force this password to see if we could brute force this password. And that's where this other parameter comes into place. Here I've already found it, so the password was secret, but I'll show you how I did that. So all I did was to copy this command, paste it here, and so what we're doing here is We're trying to look for the password here, but already found it here. So what I did in this instance was not using W4s, was to use intruder. So if we go on to repeater, we've got this. And what I did here was to send this to intruder. Go on to positions, clear, highlight the password parameter here, click on add, go on to the payload, and a simple list, click on load, and selected the root txt rocku.txt password file. So that should be in USR share and go into word lists. Word list, and then select rocku.txt, and that should load in here if everything is working fine, and we should have a password payload count as 1. Just so Bob hasn't hung up on me. Just want to show you how I was able to brute force the password for secret. For some reason, I'm not getting a response from Burp. I think it's frozen on me due to, I don't know, some weird reasons. If I click any of this, it's not happening. So what normally should happen is you should load the file, and once I click on Start Attack, it will try to brute force for the password for that parameter called password. Not getting a response from Burp. Okay, so let's get back to where we were. So here, I found the password called secret, and I hope Bob responds so I'm able to. So let's see if I can open on the burp session. Just hope there's nothing going on in the background for burp to not behave itself. So here it's not allowing me select this because I've already got another burp instance running. So let's see if I'm able to close this. So quit. So what I was hoping to do is to be able to send this request again after brute forcing the password. So here, I think Bop has probably popped up again. So I click on that same file to see if he's going to respond this time. Nope. Sometimes it's weird, doing live videos and things just don't just work. So I'm hoping this is going to be a short video, but with the way things are going, it appears probably might take longer. Right. Try to see if I can quit this window. No lock. Hmm. Come on. Okay, anyway, we couldn't find that. On the other hand, using Derb, web directory scanner and supplying HTTP 10.10.10.86, trying to brute force any additional directories that might actually exist on this HTTP service, and running the scan. After a while, we're able to find a web directory called sockets. I think because my intercept is still on, this is actually taking longer. I don't know why Bob suit isn't responding. So what I'll do is I'll go on here, and probably if I turn off the proxy, it might respond. Okay, so it's responding now, and we found a directory called socket, and here it's giving us a different message saying missing parameters. So we can view source, and there's nothing quite interesting there, saying there's some missing parameters in here. So armed with that information, what I did next was to try and force, yeah, click on yes there. I think Burp has come back to his senses. Go on to options, click on that. I think he's responding now. So we found this, as I was mentioning earlier on. So I'm going to go in here, preferences, advanced settings, set up proxy again. And going back to Burp, intercept is on, send this to Burp. You can see we got the same cookie information, and I'm just going to put in the password equals secret. So assuming everything went fine with the brute forcing, and send this to repeater, click and go. And here it's saying missing parameters. So what I did in this instance was, since it's saying missing parameters, was to try to brute force whatever parameters we're actually missing. So using the command w-force, looking, saying highlight the code, which is gives us a 200 response, provided a password cookie, which is called this, username, and then trying to brute force for the parameters for the for this. So if we go back to burp, it's saying missing parameters. So what I did in this instance was to again go onto the parameters, click on add. In the URL parameter, we create two parameters here. So I'm just going to call this hello and the other one test. Click on go. And you can see burp here is saying still missing parameters. So if we go onto the proxy, to repeater, click on go. To the raw message and repeater, click on go. We still have the missing parameters, but we can see here we've got hello and test as the two parameters that we need to brute force. So this was the information I was using in order to force for what this parameter names are actually called. So after using w-force, we're able to detect that the parameters missing is actually port and command CMD. So armed with this information, going back to burp, we call this port, and then we call this CMD. I'm just going to provide some information here. So port 80 and command, I call it test. Click on go. We get a response back saying a bad request. If we go on to render, we get this information here. So if we go back to the web browser here, we can actually put in the port equals 80 and CMD equals test. And then we get this request, and this is saying TCP socket test status of catch engine online. So I try to look at some of the ports we got. If I put in test here, I get a response regarding the HTTP service. So the next thing I did was to try to brute force if there are other ports that are actually on the local host that are accessible from the inside but not accessible from the outside. So using this command, w-force, paste that in here. We're trying to scan for ports that are actually running locally on the machine. So we can see port 21, which we found earlier on, that's the FTP 2280. And w-force continues to search for any other open ports. So we specify the range of ports to use from 1 to 65,535. So w-force continues. I tried using burpsuit to do this, but it took actually longer until I figured out how to do this. So eventually, so I'll just let that keep running. But to save time on this tutorial, we eventually found a port 11211. And once we found these ports, you can see if I put in a port that doesn't exist, so let's say for instance we put in a port equals 300, we get an internal server error if the port doesn't exist. But if we put a port like 22, we get a response. So eventually W4's found port 112112 and we got a response. So I did a Google search for ports 112112 and found out that memcache, which is similar to Redis, actually uses this ports. So W4 is still running, and I read about it to see, there was some vulnerability associated with this, but the most interesting thing I found was port 112112 commands, which I searched, and found a cheat sheet which talked about how you could actually send some types of commands. So you can use get command to do a lot of stuff. But interesting one I think was using the stats command. So let's go here. So if we put in stats, say missing parameters, so 11211, we get some responses. So if we go in here and put in 112112 and using the get items command, nothing came up. So let's try stats items, submit, and we're able to list a lot of items that are actually on here. So according to the cheat sheet, we could run some commands such as stat. So you could do stat catch dump, and we could supply. So we got here 16 as the item number. So we can do 16 slash for the first 100. So get the missing parameters there. So I need to put in the port number. It tells us we got an item listed as stock. If you remember from the login page, we actually found a list of items called stock. And then I did start items. So we have that. Then I did for 112112. And then we do get items. Gives us an error. 112112. Start items. Get the items. Then we could do start. Well, we could do get items. No output. Start cache dump 1600. And here it tells us stock. I think the next one was start get items 2600. And this time around we get something called item users. So let's see here, if we did this and did get stock, let's see what will happen. Nothing. Well, here if we go in and then do get users, we get a database or JSON file with a list of usernames and what appears to be MD5 hashes. So what I did here was to copy this JSON file, file.json, I think. I copied out this JSON file. So let me just go back to burp. And you can see to W4s, W4s has found that port 112112. So I'm just going to end that brute force here. And that was how I figured out the port number we could actually access internally. So if I go back in here, we could see here, and this is the JSON file. So I tried as much as possible to to edit this for just the username and passwords, and I put into a new file. I think I call the file new.txt. So I got all the usernames and all what appears to be the password hash. So next thing I did was to use John, specify the word list to use. So word list equals USR share word lists, and then rocku.txt. Specify the format to use equals raw-md5. I think before that I have to specify the file itself. So the file is actually located in my downloads folder. So I have root/downloads/new.txt to try to see if John could actually crack the passwords. So straight away, John was able to crack all of these passwords. So we have admin, Abigail, monkey as passwords and all the usernames. So using Hydra, or just trying to check these usernames against the password using SSH. So I did, after trying everything, I found out that the user called Genevieve at 10.10.10.86 supplied a password called Princess1. And there we go. We got a user shell. So list. I think actually people have been on this box, but normally what should be on this box alone should be user.txt. So I should have reverted this box before looking at it. So we got user.txt as the text file, as the user file hash. So we could do wc-c user.txt, and then we can see the 33 characters of the MD5 hash. So how do we do privilege escalation? One thing you could do is you could download linum.sh, which somebody probably has done on this box. So if you do linum.sh, if I could spell that correctly, I get linum.sh by reboot user, which you could use to enumerate for information or information about on the box in order to conduct a privilege escalation. So let's see if this one from this works. So if we do a bash linum.sh and try to run this, so we can see the user Genevieve there. So I'm just going to scroll to the top. So we can see the name of the kernel is Linux, running kernel 4.4, 64-bit Linux machine. The version of Linux is that. And we have some other information. Hostname is Dab. Got users are logged in as root and also Genevieve. And we got a lot of information on this. So what I did here was, after a lot of enumeration, you could just do Linux privilege escalation. And I think this one here, I enumerated for any SUID files that might actually be, SUID scripts. So scrolling down here, exploiting SUID executables, we can actually use this command here to find any existing SUID binaries on the box. So straight away, I put in this command, and we can see all the list of the ones that are here. But the one that caught my eye was this user bin myzec. So it was what checking this out. So we do list, long list, paste that in, and we can see it's highlighted in red saying it's a SUID bit is set, and every user can actually execute a script. So copy that here and try to just execute this, see what happens. So we're prompted for a password, type in anything there, and it says invalid password. So try to see if GDB is installed on this box to see if we could actually reverse engineer the box, and we get no response about GDB. We got no response. So I do a which GCC. GCC is actually installed on this box. So the next thing I did in this binary was to run the command strings. Okay, and then we could see some strings in this binary file. So we can see it uses certain libraries, a library called libsec login, some other information such as puts, printf, string compare, and some other information. So the next thing I did here was to find out how this box, or actually how this binary works, was to run this command called ltrace and supply the path to the binary. And here we can see it begins with a main function. Printf asks us for a password. So let's say we put in any password here, any gibberish. It does a string compare to this weird secure login, comparing it to a password. If it matches, it should print out the password is correct. But here, because we provided a wrong password, it prints out the invalid password command. So armed with this information, we could do this. Run the script again. I think I might have actually lost the shell. The shell broken. See if I can log in again. Princess 1. Okay, I'm dropped back into the shell. And let's just repeat the command we did earlier on. So we did ltrace usr/bin/myzec. Should have a space in here. Okay, so we supply let's try to get that password again. So secure login as the password. Okay, so when we try to run this again, supply the password, put in the password, and then it says password correct, and then saying sec login function is called. And here there's a message saying to do placeholder for now, function not implemented. So what I did was this sec login function, try to find the sec login function on the box. So set locate function, and then we can see we've got a header. So seclogin.h. We also got this library. So if you remember when we use the ltrace, or when we use the strings command, we found this library inside of here. So we can also use ldd to enumerate the binary to see the list of libraries it's actually using. So here we can see is using the seclogin library, which is this one here, and also some built-in Linux libraries. So here we found this file. So what I did was here to actually have a look at this file itself. So you can cat this file and see what information we've got in this binary. So it's an external. So we have a studio std standard IO header, and then we have a declaration of this seclogin function. So if I go back to my command list, What I did here was to create a, my own malicious seclogin header, and then created a seclogin binary, which when compiled would be used to generate the libsec login, malicious libsec login library. So let me just list that again. So let me show you what this looks like. So we got sec login, and here sec login using some standard headers, standard IO, standard library headers, and also I then included the sec login.h. But you can see here you have to use code because this is not actually a standard C library. So this is a custom header. So that's why I am actually putting this in quotes. So void sec login, set UID equals 0, and just create a binary in the sec login. Let's have a look at the .h. And the .h is just declaring this void sec login, and also using the standard IO and the standard library headers. Okay, so going back to the commands, you have to then compile the library. So I put in here, to compile the SO library, we have to use this command. Okay, so clear screen again, list, cat the seclogin.c binary, copy that. Okay, so you can see the box has been reverted, and this is normally the only file we should have. So I did a nano seclogin.c, paste that in here, nano seclogin.h, cut the file, copy that in here, save that in. So we have both files. Okay, and then compile the file using the this command. So cat commands. So we're using GCC to say this is a shared library, and using the seclogin malicious C file, the binary I created earlier on. So put that in here, and it compiles. So if you have a list, you have 3 files, which is the libseclogin.so, we have this and this, but this is actually the one we need. So the interesting thing I did here was, right, how do we then, because if you remember when we did the LDD on the malicious binary, or on the SUID binary, sorry, bin.myzec, we can see he's actually using these libraries. This is the one that probably was, put on the box, and here is the location for the binary. So the question is, how do we then point this, this SUID file to actually use our own malicious binary? So, to point it to our own directory. So I came across this blog post after doing a lot of information, and it says here, how do you specify the location of libraries to a binary? And a guy happened here to be having issues, and there was a good response on how to do that. So using the LD library part, you can load the library to the executable file, or you could create a custom script or a wrapper that points to the directory where you actually have the binary. So this is the file I created. So I create nano, and I call this roots.sh. Paste that in here. Changed the path here to the path where we have for the binary itself. So here we have usr/bin/myzec. And here we have the path to the binary itself, or to where we have our malicious library. So in here we have home stop Genevieve, and also we have to do the same here as well. So here we have home slash Genevieve. Okay, so that looks fine. Going back to the blog post, the guy actually mentioned here that what you need to do is the list of standard libraries are kept in this file, in this configuration file. So he says recent systems allow files to include other files. So if yours contains the include etc/like config, create a new file called this. So let's have a look at this file. So if we cat this file, I think I've actually lost my shell again. This is annoying. I think people are actually resetting the box. Okay, so it's responding now. That's good. Let me do a list to be sure my files are still there. They are. So if I do a cat this, we could see here it matches what it was being described here, that you should have etc and you should have asterisk.conf, which is what we got here. So here he says in the blog post that create a new file called this. So create a new file called this, containing directories. So what we have to do is just copy this, go into a shell, nano, paste that in, and then it says here, copy this containing directories you want to add after you change this. After you change etc.love configs on an included file, run this command. So what we have to just do here is put in home slash Genevieve, and then go ahead to run this other command here, which is the sbin ld config, and it says that would then update the cache. So let's go back in here and run this. So we've done that. So we do a list, we got a file, and then let's try to use that the script we created. So we could do bash, enter password. Remember the password was secure login, wasn't it? Yep. So it prompts us for a password. Go in here, put in a password, and we root. Brilliant. So we root, and if we do a cd/cd/root list, and we got the root flag, so we can do root.txt, and there we go. We root on the box. So it's quite complicated to understand, but I think if you go in here to read this blog post, how do you specify the location of libraries to a binary? You can have a look at this blog post, and it actually describes it much more in detail, probably much better than I have done. So it's about just pointing the library, the malicious library which we created earlier on, which is this, by compiling these two files and pointing the binary which we want to use. So myexec, if you remember in the root sh file I created, which was based on what the blog post suggested here, and then pointing the library part to our home directory, because the home directory is where we actually have the malicious SO file or library file. So by doing that and executing that script, putting in the password's correct, it executes our malicious library by loading the library, and then we root. So I hope this explains the box. This box actually was very, very painstaking, but I think I learned a lot actually doing this box. So thank you for watching, guys, and I'll see you next time.